The join clause is one of the most commonly used clauses in SQL and can be used to query and combine data from multiple tables. Hey guys, my name is Ali and I'm a data analytics manager working in Oslo, Norway. In this video, we're going to take a look at using joins in SQL. We will focus on two of the most used ones, which is the left join and the inner join. First up, we will break down the syntax and from there look at some specific use cases and discuss when these joins are useful. This is the first example that I want to take a look at, and it is a traditional left join. So if we take a look at the syntax first, you can see that we will be selecting some columns from a table, and then we are going to left join another table on a certain condition, and that is what we are going to do. So you can see what we have selected here is we have, let me see if I can get everything. We have a product key, a subcategory key, we have a product name, product description. You can see I have something that I have joined in, which I have commented out for now. We have the status from the dim product table. I have used a table alias P. So you can see there's P dot, and everything. And then there's PS. So the P stands for product, PS stands for product subcategory. Then I have my join condition and I have a couple clauses. So I've said that I want products that are current, and I don't want any rows where there is missing a product subcategory, just for the sake of the example. And what does that give me? That gives me this table right here. Nothing special, to be honest. And what we are going to do is we are going to bring in the subcategory name. Now what's important to notice here is that I have first of all used a table alias just to make it easy to understand which columns is coming from which table. And then I am going to do a left join. And what I'm doing here is I'm doing a left join between two dimension tables. And that is because often when you are building a data model to do analysis on, you want to restrict how many steps away from the fact table you are when you are doing analysis. So what's happening is that the dimension table that I'm joining into is the product table, and where I'm joining from is the subcategory table. And that means that if I have something in the fact table, which is in a data model connected to the dimension table, and from there connected to the subdimension table, if I'm using something from the subdimensional table to do analysis in the fact table, you can see that there's two steps. There's one step here, there's another step there before the filter reaches the fact table. Now I want to minimize how many steps. So if I take values from the subdimension table into the dimension table, there's only one step away from the fact table when I'm doing the filtering, and you know, it's just best practice, because what you're looking at here is a dimension diagram, and the reddish ones are one step outside. Let's, you know, what is this, orange? So the orange one is what we call a star schema, but with the red tables outside, it becomes a snowflake schema. If you take values that you need from the red into the yellow, you stay consistent with that star schema. So it's a little bit of data modeling in here, but today I'm doing two different left joins. I'm going to do two left joins. I'm doing it from the subdimension table into the dimension table to minimize the need for more tables. And the other thing is I'll join the dimension table into the fact table to create a view, which is another thing. I'll come back to that later. So what you can see is that I'm going to left join in from the dim product subcategory as PS, which is the renaming, and then I define what am I going to join on. So I'm going to join on the product subcategory key, which I have in the product table, which needs to match the product subcategory key. So you can see anything in this table now that has the alias PS, which is this column, has been joined in based on this condition. And when you do a left join, it means that everything is going to stay as is on the first table, which in this case is the product table, and you're going to join in, you're going to add new information from a second table and only where this what is it called, where this comes back as true, where it evaluates as true, it will add whatever new columns you want to fetch. But if it doesn't fetch anything, it's just going to turn into a null. It's not going to add anything. So you keep all of your information from the first table and you add on from the second table, and where you get a match on your join condition, you will get whatever it is that you were fetching from the second table. So let's run this one. So we go execute. I just need to connect to the instance. I'm on the wrong one. 1 second. Let me do that again. There we are. Now you can see that I have added the subcategory name, which has come in from a different table. So it has joined in the subcategory name based on the key, the product subcategory key, which it finds in the product table, and the corresponding one it finds in the product subcategory table, and it's fetched in the subcategory name. So if I had two tables, I had one named subcategory and one named product, in theory I wouldn't need this extra table, and we have reduced one step in terms of the analysis model, if that is what you're using the left join for. Another thing you could be doing with left joins is that you have what we call a fact table. Now let me take this back to its original state. So it's the same concept. I have fetched some columns from the table, which I'm now given a alias with sales. So it's from fact internet sales as sales. And one thing that's, I want to point out, when you read joins, you want to read from, you want to start, you have a select statement, that's fair. And then you go down and then you look at what is the join, and then you go back up and you read the different columns so that you can understand what has happened between the tables, what are the different tables aliases, and where are they coming from, and then you read the column names. Don't read from the top bottom down, because it can get a little bit confusing. If you read what is going on down here first, and then you read the columns, then you know what has been filtered, what has been removed, what has been added, and then you read the actual column names. But let's stick to this one. So originally, I have a product key, I have a order quantity, I have sales amount, I have order dates. I only have columns, which makes up a fact table. It's a very basic fact table, but it's a fact table because it has a key that points to some sort of dimension table. It has a order quantity, a sales amount, and a order date. Now when you combine dimensions and fact, it becomes what we call a view, where you have combined both the categories or the lookup tables and the actual fact tables. So here I joined two dimension tables to create one dimension. Here I'm joining dimensions into the fact table to create a finished view, which you might also do sometimes if you want that all combined in one place. So what we're going to do, I'll comment this one in, I'll comment in the left join. So we have left join dim product. So we're going to join in the dim product as the alias is just AP on sales dot product key equals p dot product key. You can see I have renamed the fact internet sales as sales, and that is what I'm going to join in. So when I do that, now I have the product name also. So in theory, you could remove the product key. It doesn't really tell you anything anymore. And then you have what you need. But now you're mixing dimensions and facts, so it's becoming what we call a view, which is a little bit different. And if we can refer back to the diagram, what you've done now, you've taken a dimension table and you have joined, you've taken something from the dimension table and you have joined it into fact table, which makes it into a, let me see if I can do this, a view, which is a little bit different. You don't need to do it, but if you want to get everything in together because you're doing it for a specific purpose or a visualization tool, that's what you have now. Now the last join that I wanted to take a look at, which is also widely used, is the inner join. Now you can see now I have taken the same table, the product table, but I have changed it a little bit. Let me make sure that this one works. I'm connected. There we are. Okay, it works. So I have selected, I have selected some columns from table 1 and inner join table 2 on a specific condition. So what I've done, I've selected some different columns. You can see once again I have the alias on the name, so that is the product table, and I'm going to inner join it. It should say inner join on this one to combine that. Now what's a little bit different is I have the where status equals current, so I only want current products, and I want products between 200 and 234. And the reason for that is I want to show you guys what happens with the number of rows. Let me see if I can get that also into the picture. I can't. But I want you to notice when the product subcategory is null, what happens to those rows when we are do the inner join on and off. Because what's going to happen is, since we are joining on the product subcategory key from the product table and using that to join against the product subcategory key, so the inner join works in this way, that it is going to combine rows from both sides that you have defined from the left table and right table, where it gets a match on your condition. So the condition is that P product subcategory key equals PS dot product subcategory key. Where it does not match, it's not going to return anything, because that's how the inner join works. It returns something if it matches on both sides. So you can see now we have 19 rows just for the demonstration purposes. Execute that, and you can see it only returns the values where it is getting a match on both. And you can see now I also have the subcategory name here. So some of the rows went away, and that is because those were there were nulls. So if you know what you want from the first table, you know what you want from the right table, and you want to combine those, and you only want what is common for both tables, that is when you use the inner join. Just to touch on it, the right join is quite similar to the left join, except that you are joining from the first table to the second, from the left to the right. And a full join just combines the result from both tables together. But I think the left join and the inner join are important joins that you need to understand and that you will use in different cases, either if you are trying to combine some tables, some dimension tables, or if you're trying to add tables to a fact table to create a view. Those are some of the ways you can use joins in SQL. Order of operations becomes really important when you're starting to combine data from different tables, and also remember to use table names to make it easier for yourself to understand which columns comes from which tables as you are doing the join. If you like this video, then give it a thumbs up. If you want to see more videos on data and analytics, then subscribe to my channel, and I'll see you guys in the next video. Where's my phone?